So in this next example, we're going to be looking at an electron. This electron is moving at 7.5 times 10 to the 5 meters per second, and it enters an accelerator, and it emerges moving 4.0 times 10 to the 6 meters per second. If the accelerating region is 2.5 millimeters long, what was the acceleration, assuming that it was constant? So let's draw a little diagram on what's happening here. So we have an electron, and it's moving at 7.5 times 10 to the 5 meters per second. And then it enters into an accelerator. I'll draw a little box so we can see it's some kind of machine or some kind of unit, and then it emerges moving at 4.0 times 10 to the 6 meters per second. And what do we know about the accelerating region? That it's 2.5 millimeters long. All right, so now it's always a good first step when looking at these problems is to kind of visualize, draw a little sketch of what is actually happening. And then after that, we can move on. This is our step number 1, as you will have known if you watched the previous examples. That is to organize our variables. So what do we have? We have an electron moving 7.5 times 10 to the 5 meters per second. That is our V1. It's our initial velocity. And then we have the electron emerges moving at 4.0 times 10 to the 6 meters per second. That is our final velocity, or V2. 4.0 times 10 to the 6 meters per second. Then the last piece of information is that the accelerating region was 2.5 millimeters long. So what does that mean? Well, that means that the distance that our electron traveled during this acceleration was 2.5 millimeters long, and that is a unit of displacement. And then the fourth variable, which is going to be the one we're looking to find, is the acceleration. So what is the acceleration? We're not sure, so that is our unknown variable. Now there's one more step I'd like to do before we move on to step 2. One more little thing that we should do. It's good practice. You'll see that the units here are in millimeters, and the units here are in meters. And we want our units to be consistent throughout the problem. That'll make our solution easier, and it'll make it accurate. So whenever you see these millimeters, you want to convert them into meters. So the conversion from millimeters to meters is times 10 to the negative 3 meters. And that will be the value we're going to use further into the problem. All right, so moving on to step 2 now. We've got our variables organized. Now step 2 is to choose an equation. So we have our 5 equations over here, and we're going to choose which one to use. All right, so how do we do that? Well, we look at our variables that were given, V1, V2, delta D, and then the one we're looking to find is acceleration. So which equation includes all the variables that we're using. Well, looks like equation 5, v1, v2, delta d, and acceleration are all used in this equation. So that's going to be the one that we're going to use. So v1, v2, delta d, and a. So therefore, we are going to use equation number 5. Right, on to step 3, where we plug in the variables. So let's rewrite our equation 5 here. So v2 squared equals v1 squared plus 2a delta d. So we're going to plug in the given variables into our formula now. So our v2 is 4.0 times 10 to the 6 meters per second. And our v1 was 7.5 times 10 to the 5 meters per second. It's this value here. Plus 2 times a delta d. So a is our unknown, so we're just going to plug in a. And then d, remember to use consistent units. So we want our value in meters. 2.5 times 10 to the negative 3 meters. All right. Now, simplifying this, we're going to use our calculator, plug these in. You're going to get 1.6 times 10 to the 13, and then the units on that will be meters squared per second squared. And then on the other side of the equal sign, we plug this into our calculator, and we're going to get 5.625 times 10 to the 11. Then the units on that, meters squared per second squared, plus, here. Now we can multiply the 2 times the 2.5 times negative, or times 10 to the negative 3. That'll give us 5.0 times 10 to the negative 3. That's multiplied by our unknown variable a. Let me rewrite that clearly. A. Right, and that brings us now to step 4. We rearrange to isolate unknown. So our unknown variable here is a. And step 4 tells us to rearrange the equation. Oh, I forgot an E on there. Rearrange the equation to isolate for the unknown. So that means bring in our unknown variable to its own side of the equation. So what we're going to do here is bring our 5.625, bring it to the other side of the equation. So 1.6. So it's going to be the same equation. The only thing we're moving is the 5, and remember when we're switching value onto the other side of the equal sign, it will become a negative. So this step is simply just rearranging the equation that we already have, and that is equal to 5.0 times 10 to the negative 3 meters times acceleration. Okay, and And simplifying this further, to isolate another step, what we need to do is bring this term here onto the other side of the equation. And since it's a multiplication here, this is multiplied by a, that means on this side it's going to be a division. So here we're just rewriting these terms. I forgot the e squared on that s. And now a division over 5.0 times 10 to the negative 3 meters. And that is equal to a. So now that we have our a isolated, we can now plug in this big mess into our calculators. And I recommend that you try this along with me. I got an answer here of 3.0875 times 10 to the 15 meters per second squared. Keep in mind the units. Here we have meters squared per second squared, and that's divided by meters, so that will get rid of the meters squared and turn it into meters. So our final units here will be meters per second squared, and that is what we are looking for in acceleration. That is the correct units for acceleration. And just before we finish off here, we want to look at significant digits. In our question, we're given 2, 2, and 2. So our final answer will also be in 2 significant digits. So 3.1 times 10 to the 15 meters per second squared. Write the a in front. So acceleration is equal to 3.1 times 10 to the 15 meters per second squared. And that is our final answer.